Hey, if those electron configurations are just driving you crazy, you're not quite certain if the 3p comes before a D or an F or an S, this is what you need to do. You're going to write yourself a little table to help you remember what orbitals come in what order. First, you're going to write all the period numbers. And of course, these are the n numbers, right? The main level, the main quantum number. Of course, they all have an s level. So these are your s orbitals. To that, we're going to add the ones that have a p. 1 doesn't have a p, but 2 has a p. And 3 has a p, and so does 4 and 5 and 6, of course, and 7. Then we have SPD. A D level comes in on the third N, so 3D. So you're writing this for a little while, but it's well worth it because it really solves the issue of what comes first. And then finally we have an F level that only appears on the fourth period N down, so we write it for those. We're not going to continue, we're just going to leave it like this. Alright, so what do? Well, I like to draw diagonal lines that are going to help me figure out how I'm going to follow this. So the diagonal line comes from above and goes on like a 45-degree angle south and to the west. Alright, so it's telling you that the first level that comes up is 1s. The second level that comes up is 2s. Then comes 2p and 3s. Very expected so far, nothing out of the ordinary. 3p, 4s. It's all good. What was all this trouble all about? But note that 3d sneaks in 4p and then 5s. Before 4d is actually done on 5p and 6s. And if you continue your diagonals, it's really going to help you predict even the longest configurations ever. Let's test that out. Let's say you're going to do tellurium. Tellurium is element number 52. So I'm looking at the periodic table, of course, because I have it right in front of me. Like everyone should have the periodic table in front of them, right? And I can see that it's in the P block, and it's right on the oxygen group. So I'm going to start it out. Now I like to see where I'm going, so I'm going to actually highlight period 5. P block should land me on a 5P. So I'm going to highlight that on our diagram to know where I'm going to stop. You don't necessarily need to do that, but I like to do that to know where I'm going. Kind of give me a little hope on when is it going to end. Okay, so I'm going to start with my 1s. 1s, and I know the s level holds 2 electrons. I'm going to go to 2s. Another 2 electrons. Then 2p. That's going to hold 6. Then it says it's 3s. That's going to hold another 2. Let me show you how I'm reading this thing. So I read my 1s, 2s, 2p, 3s. So that's where I am. Immediately I know that I have to do 3p, 4s. Those are very easy to figure out. They go in order. 3p with 6. 4s with another 2. And this is where the tricky part starts, that 3d actually comes in, and then 4p and 5s get filled in. So after my 4s, I'm going to go to 3d. And a D level, SPD D level gets 10 electrons. 4p, that's another 6. And the 5s gets 2, the s right there. Let me see where I am. I'm on 5s. I'm going to go to 4d, and yay, 5p so I'm done right here. So those are the last two I need to place in there. I'm gonna go 2, 4D, that's gonna be 10 of them, and 5B, thank goodness, because my screen is done. Now, here's the question. A P level can hold 6, but since I'm ending my configuration, I need to figure out how many electrons do we have on that P level for that particular element. Tellurium, it's in the oxygen group. I can count 4 spaces from where the D block starts. So I know that this is going to be a 5B4. Not the 6 of them, it doesn't have 6. It would be the noble gas if that was the case. It would be a full shell. This is not a full shell, it's 4 electrons only. And why not confirm if we did this right? We could go ahead and add up all of these electrons. The 2, and the 6 is 10 electrons. Another 2, 6, and 2, that's another 10. Here's another easy 10. And 6 and 2 and 10 and 4 is going to give us actually 22 electrons, which is actually 52 electrons, which is perfect. That tells us that this is tellurium, and so that we have done a really great job. But if you're feeling like this is entirely too long of a notation and this should be a better way to go about this, or a shorter way to go about this, you're absolutely right. So check out our next video on noble gas configurations to figure out what's the shorter route to this. All right, see you then.